This is Atusa Amini, and this is my Teach 1 for the topic Benchmarking and Clinician Profiling. First, we will find the expected length of stay for Dr. Smith. The figure shows a decision tree. We see that the probabilities for the first path, which shows 4.5 days, is 0.25 and 0.15. For the second path, which is 5 days, the probabilities are 0.25, 0.85, and 0.70. The third path has 4 days, which corresponds to 0.25, 0.85, and 0.30. Note that 0.85 and 0.30 are not directly written on the tree, but to calculate it, we must do 1 minus the probability of the event that is written. The fourth path has 3 days, where probabilities are 0.75, 0.85, and 0.70. The fifth path has 4 days, where probabilities are 0.75, 0.70, and 0.15. The sixth path has 2 days, with probabilities of 0.75, 0.30, and 0.25. And the last path has 4 days, with probabilities of 0.75, 0.30, and 0.75. In Excel, we will write all these probabilities down on one column, and on the next column, we will enter the days on the next column in Excel. The next step to finding the expected length of stay for a clinician is to calculate the joint probability, which multiplies the probabilities associated with each path. After that, you should multiply the joint probability for each path with the outcome, in this case is the number of days for that path. The next slide shows how these calculations are done. Once you have entered the probabilities and the days, you can calculate the joint probabilities for each path. As you can see, the probabilities of the events are multiplied in each path. We start from the left to the right of the decision tree. The first path on the decision tree has probabilities of 0.25 and 0.15. So these are multiplied, and you can see the joint probability is 0.0375 for the first path. The second image to the right shows how to find the length of stay for that path. We simply multiply the days associated with that path, which in the first path is 4.5 days, and we multiply it by the joint probability that we found. This gives the length of stay for that path. This to be continued for each pathway in the decision tree until we can find the sum. When taking the sum of each path length of stay, we see that 3.6075 days is the expected length of stay for Dr. Smith. For Dr. Jones, we will use the same procedures where we fold back the decision tree to find the expected length of stay. After finding the joint probability for each pathway and multiplying it by the number of days for each pathway, we find the length of stay for that path. When summing up the length of stay for each pathway, Dr. Jones has an expected length of stay of 4.67275 days. The next part of this assignment asks to find the expected length of stay for Dr. Smith if he were to take care of the patients of Dr. Jones. To find the expected length of stay for Dr. Smith, if you were to take care of Dr. Jones's patients, we must think about whose outcomes to use and whose patients to use. This means we will combine the decision trees from both Dr. Jones and Dr. Smith. We will be using Dr. Jones' probabilities since it is Dr. Jones's patients, but we will be using Dr. Smith's days. We then do the same procedures that were used to find the expected length of stay for each clinician, but the joint probabilities and outcomes are swapped in this case. Most of the joint probabilities were already calculated during the first part of this assignment when we found Dr. Smith's expected length of stay. However, the first path will be different because Dr. Smith had 7 days, where Dr. Jones has 8 days. Then we will calculate the length of stay for each path. When following the same procedures and summing up each length of stay, we see that if Dr. Smith were to take care of Dr. Jones's patients, the expected length of stay would be 4.25975 days. Now we will look at a scenario where Dr. Jones takes care of Dr. Smith's patients. Here you can see I combine the decision tree of both providers. The left has Dr. Smith's probabilities and the right has a length of days for Dr. Jones. After you enter the probabilities from Dr. Smith and the outcomes from Dr. Jones in two separate columns, we will find joint probabilities. Most were already calculated in the other part of the question, but because Dr. Smith's event tree did not have a probability, as it had one less outcome, we will assume it is the same as Dr. Jones's probability for the first branch, which has an outcome of 7 days and 5 days respectively. This is why we added a branch from Dr. Jones's tree. Then you are ready to multiply the joint probability for each path by the number of days on that path to find the length of stay. As you can see, when finding the expected length of stay for Dr. Jones, if you were to take care of Dr. Smith's patients, the first two joint probabilities are different. We must multiply 0.25 and 0.15, which come from Dr. Smith's decision tree, by 0.30, which come from Dr. Jones's decision tree. This is because this corresponds to 7 days, which is Dr. Jones's days. For the second path, we must multiply 0.25 and 0.15, which is from Dr. Smith, all multiplied by 0.70, which is from Dr. Jones's tree. This is because the path corresponds to 5 days. The reason we must make this change is because Dr. Smith had one less event branch with probabilities because he had less outcomes. But we will assume the probability is the same as the other provider, which is why we pasted Dr. Jones's probability so it can match with the outcome. When following the same procedures and summing up each length of stay, we see that if Dr. Jones were to take care of Dr. Smith's patients, the expected length of stay would be 3.68125 days. Thank you for watching.